Very well, good morning to everybody. In this lecture, we will study about unit second. Unit second will be of size reduction. All of you who know that what is size reduction. It is a simple term which states its explanation. Size reduction means to reducing the size of a particle. किसी भी पार्टिकल के साइज को छोटे करने को हम बोलते हैं साइज रिडक्शन. Size reduction are commonly done by the forces that is stress, compression, impact, attrition or cutting. So compression is when we apply the force on that is compressive force. Impact is the sudden force applied on a particle. Attrition means the rubbing, that is attrition, and cutting is used for reducing the particle in the particular shape and size. So if we have to reduce these particles in their size, we need some power for that. We need some energy for that, and on the basis of that energy, its efficiency can be calculated or can be determined. So we have three power laws for calculating the power required for the given reduction. First one is the Rettingers law, second one is the Keck's law, and third one is the Bond's law. So first of all, I will discuss about the Rettingers law. So Rettingers law is given by the Rettingers. Rettinger is the name of a scientist. This law states that the work required for reduction of particular size is directly proportional to the new surface area created. Means new surface area created means difference in the area. Means original area and the final area, or we can say that the original size and the final size. Obviously we are reducing the size, so original size is more and the final size will be less. So according to Rettinger's law, we will obtain mathematically that P upon m dot equals to Kr bracket 1 upon dsb minus 1 upon dsa. Here P is the power required, m dot is the feed rate, Kr is the Rettinger's constant, dsb is the product diameter, and dsa is the feed diameter. These two diameters are always taken in meters. Be sure of this. Okay. Now second one is the Keck's law. Keck's law states that the power required is directly proportional to the logarithm of the initial diameter and the final diameter. Initial is more, so it is represented by capital D. Final will be small, so it is represented by small d. हम प्रोपोर्शनलिटी का साइन हटाएंगे तो एक कांस्टेंट की वैल्यू आएगी. सो आई हैव पुट द कांस्टेंट के के. सो अकॉर्डिंग टू Keck's law, it is P upon m dot equals to k k ln of d upon d. As the energy, so in this formula you can use diameter either in meter or mm because it is a ratio and it does not affect the final value. Now next is the Bond's law. In Bond's law we have used the new term that is work index. Okay, and Bond's law is the intermediate between Rettinger's and the Keck's law for estimating the power required. Bond suggested that the work required to form a particle size dp from very large feed is directly proportional to the square root of the surface of volume ratio of the product. स्टूडेंट्स आपको बॉन्ड क्रशिंग लॉ यूज़ कब करना है? अब जनरली क्या होता है, इनके न्यूमेरिकल्स आते हैं आपको सॉल्व करने के लिए. Keck's लॉ, Rettinger's लॉ आप कभी भी यूज़ कर सकते हैं. अगर उसने स्पेसिफाई किया है कि आपको Rettinger से करना है, Keck's लॉ से करना है, तो क्वेश्चन बिल्कुल सिंपल है. अगर उसने स्पेसिफाई नहीं किया है तो आप Rettinger's या Keck's कोई सा भी यूज़ कर सकते हैं. लेकिन अगर आपको बॉन्ड्स लॉ यूज़ करना है तो वो बॉन्ड्स लॉ ही यूज़ होगा. और बॉन्ड्स लॉ की सबसे अच्छी पहचान क्या होती है, आइडेंटिफिकेशन क्या होती है, उसके अंदर लिखा होता है कि दैट 80% ऑफ प्रोडक्ट विल पास थ्रू दिस एंड 80% विल पास थ्रू दिस. जहाँ पे भी आपकी 80% की बात हो जाती है वहाँ पे हम अपना बॉन्ड्स लॉ यूज़ करते हैं. सो बॉन्ड्स लॉ में हमने एक टर्म इंट्रोड्यूस करी है जिसे हमने बोला वर्क इंडेक्स. तो वर्क इंडेक्स क्या है? इट इज डिफाइंड एज द अमाउंट ऑफ ग्रॉस एनर्जी इन किलोवाट आवर्स पर टन ऑफ फीड मटेरियल required to reduce a very large feed to such size that 80% of product passes through a 100 mesh screen. So you can see I have written the constant Kb equals to under root 100 into 10 की power minus 3, which will give you 0.3162 into work index. So according to Bond's law, P upon m dot will be equals to 0.3162 into work index into 1 upon under root dpb minus 1 upon under root dpa. Here A is for the feed and B is for the product. So dpa is the diameter of feed and dpb is the diameter of the product. P is the power required and m is the feed rate. So this is the power laws. There are 3 power laws: Rittinger's law, Kick's law and Bond's law. In my next video, I will help you with some numericals of these topics. If you have any doubt, just please comment and ask. Thank you.